Yeah, so eSIM on Ubuntu open source and PDK and for circuit design with Snap and Docker. So in the morning session, Professor Kanan has talked about what FOSSEE is all about. Free libre open source software for engineering education, and this FOSSEE project is basically into the promoting different open source tools. And so we also have the build two tools. One of them is eSIM and another is OSDAC. So this eSIM tool is for the electronics engineers. It is an electronic design automation tool. So some of the aspects of FOSSEE can be seen here. So you can see how FOSSEE helps. Yeah, so eSIM is basically for electrical engineers. It's an electronic design automation tool. So many of us, when we were in electronics engineering or electrical engineering, and at least I remember that I had one lot many resistors, integrated circuits, while different other things. But and yeah, so and all colleges like Tier 2, Tier 3 colleges cannot afford the proprietary tools. What this FOSSEE project has developed this tool, eSIM. It's an open source free of cost tool which the students can use it for their engineering curriculum in electronics. And it is developed by collating different other tools like Ngspice, which is a spice simulator, and KiCad, then Verilator for Verilog digital simulation, and the GSDL for the VHDL simulation, and different other things. In fact, we also conduct different activities. So we conducted the marathon and got some of the chips taped out. Some of the designs which I sent to taped off to for the tape up to SkyWater foundry. So this is what the eSIM team is all about. Yeah, so simulation is one of the things, as I told, Ngspice and Verilator, and Open Modelica interface is also one of the things. And KiCad, everyone knows, it's extensively used for PCB designing. Only added advantage is like earlier KiCad didn't have Ngspice support. We are giving the complete Ngspice support plus the simulation support as well. And so structure of discussion, we will be talking about different main idea, and then we have integrated the eSIM with different process design kits, and this how eSIM is integrated with Ubuntu distro, and different how it can be accessed on different platforms. It is available on Windows as well, but we'll be mostly discussing on Ubuntu and different things. So problem statement, what will talk about. So over to you, Varad.
Hello everyone, I am Varad. So talking about the problem statements, like as we all know, Ubuntu has like a lot of dependency we need to already being installed for any software. So firstly, complex setup procedures along with the platform dependency and the which act as a barrier for installing the software. So for EC, when we are dealing with the Linux software distribution, which is fragmented and which has many dependency to have. So to like traditional packages like Debian, Red Hat package management. So this like tied to the OS version that you install. But most of the users who are students or researchers, they likes to the system privilege or admin access to change anything in the PCs and all. So eSIM on Ubuntu offers one thing that you could install it in the form of like in the snaps or the Docker and things. So I will discuss it. Like technical conflicts, like basically OS specific is one thing, and the other side cost cross distribution like Ubuntu, Fedora, and so many things. So manual updates and these things we could be doing as of now, but as a like we now supports Docker and Snapchat. If you get these things, if you follow these things to install eSim, then it is like very easy to get installed like one click. And on the later stages, if it has some updates, so like it will be get auto updates from the Ubuntu store if it is like uh, goes from the Snackcraft and these things. So you can see this the window, eSIM window. So the main screen of the eSIM look like this. On the back side, you can see the capabilities of the eSIM, like circuit designing. You can see the PCB designing also is there, and Python, like you can do analysis kind of things. So this is the main eSIM workspace. When you install eSIM, it will pop up. It will ask you for the workspace, and then later you will create your own project. And once you are there, so on the left panel, there are some features like some functions like enter to the schematics, move, convert your KiCad to the Ngspice, and for like adding your like if you want to add your own Verilog models into the schematic, then it can be done. So for better understanding, I will show you one video demonstration. So it will be more clear how actually eSIM looks like when it get installed or when you are the first time using it. So let's take some example of voltage regulator that I created. So I will just play one video that has narrated by me and demonstrated as well. This pretty gummy. So this is the main EC workspace and this is the schematic. So you can see this is the like case circuit that are gone. This is spice simulation. Like need to create a netlist first. So netlist is generated. Now for checking what's inside that blob. So I just opening the internal circuit. So this is the internal circuit that I made from the taking reference from the data sheet. Okay, for the LM342. After that, when you click on KiCad to Ngspice, this window pop up. Here you will add the values as the parameters we say. To add the subcircuit of LM342, this is the way to add, and then click on the convert option. Once it's there, when you click on simulation, it shows the ngSpy plots and the Python plots at the same time. These are the Python plotty. So, and this marking it in and out. So after that, click on the plot. So you can say, see what's actually happening. It's a voltage regulator that I built. So it's to showcase that you can create your own ICs or sub-circuit from the TTL level, like from the transistor level, and you could design your own circuitry to get this thing simulated. What you can do, create a workspace, open that workspace, create one project. Within the project, create one schematic. In that schematic, you'll be adding all of the mm, like circuit is there. If you're following any circuit, you could do add that. And if your circuit is very complex, at that time you can take that circuit as a block, and the block is called subcircuit. So inside everything, it is there only to add these things to the main workspace. The video is demonstrated. So this is for analog kind of things. So if someone wants to build something from TTL level, like adding transistor, register, everything, then it is then you can follow the earlier video. But it's like if you're following, like if you want to do some processor kind of build, that time it is like having all transistor diodes, having wiring, doing all this manually. It's like more time consuming. So I'm just demonstrating one video. Like it's for a Verilog approach actually. So you will, as on the earlier video, there was the sub-circuit having all the transistor diodes and everything, which later called as a block and that added to the test circuit. But in this one, I will add the internal sub-circuit as a part of code as called Verilog. So yeah, we'll just check out the video first. So adding the top level Verilog border, that is the processor only. Once it added, just click on save and with the ngvery to whatever the files you're adding, all the dependencies should be there. So I'm adding all the dependency, then convert Verilog to Ngspice. Once it is done, so model I created. So that block has now created. The block is the middle one, single circle top, and again same procedure to create a netlist. Once you created the netlist, you could go to the KiCad to ingest this device console that we saw before to add the all parameters. So I got another application, it's changed. So this is just for a reference to get an idea how the GUI of the eSIM looks like. So these all are the in the Spice window that are just popping out. So if you want some item plotting, it's already there on the main eSIM window. And on the other side, you can see the command line values and all. So this is the one way to create your IC subcircuit kind of thing by based on Verilog. So as you can see, these are middle ones. So middle one is the processor, that is the 8-bit processor. So it's created by the Verilog approach basically. So the chip is there. So this bridges and all to convert analog input to digital, and then this things follows. So that's for a reference to get understand. Like if you're working on these things, so you can do simulation in the two ways. Yeah. After that, we also have a process design kits that we EPU now. So one is SkyWater and the other is IHP. So on the later, on the previous marathon that we like simulated like hundreds, like 1,000 plus circuits on the SkyWater, and this like we have a late bus minus and all the Sumanto course. I will explain this later slides. But as of now, SkyWater 130K PDK is integrated with the eSIM, and the IHP Open PDK is in the running phase. Like in 2025, we just integrated that. On the later stages, we will include the GF 180 from Global Foundries, and having this PDK inside the eSIM will help you to when you are going for the manufacturing things, and also this will really like your work will be uh, it's it's like more hands-on kind of things if you done the simulation and all, and this will work with this PDK, then you can move to the manufacturing and fabrications. So basically you go on. So as we main focus is to uh, have all of these things related to UbuCon. So eSIM on Ubuntu. So eSIM or Ubuntu, as we said, there are installation methods and all are there. To get these things very simple, to get these things easy to install. Like in Windows, we all know download the exe file and get installed. It's only one click thing. But having eSIM on Ubuntu, as of now, if we go and follow the traditional methods, so it has some script on the side, and user need to follow all of the instructions very carefully to get things done. So here on the eSIM version 2.5 that we launched on October, so we have support on Snapcraft and Docker. So you can just download that part and just get it installed on your native PC that you are working on. So like let's see, it is based for multi-user, and if for the workshop kind of thing, if we are having some like want eSIM to be installed on the large number, so it will be very easy to get installed even if it is offline. And once the it is there, so for academic and research lab, actually it reduces your time to get things installed when there are large number of machines for the workshop and all. Yeah, the methodology that we follow, that is the reproducible simulation environment on Ubuntu for long-term support, and to containerize the eSIM core modules using Snapcraft and Dropbox. That's the methodology that we follow to have this eSIM on Ubuntu to get supported for Snapcraft and Docker. So Yeah, so this is the only methodology that we follow to integrate open PDKs via Python-based middleware that we already talk about the Google SkyWater and the ISP and the benchmark performance probability with these. So constraints and limitations for eSIM on Ubuntu. So basically limited GPU acceleration and incomplete multi-arc support, and the AI assisted models are currently in progress. So we'll be introducing our AI model in maybe later versions or up to 2.5. It's one of the constant or limitation you could say. And finding significance of eSIM on Ubuntu. So basically, Snap Docker deployment models reduce environment setup. So we can say installing everything by a standard procedure and all for a beginner if he is learning, if he is in learning phase. He wants something, just click and get installed actually. Working on the software is the later part, but getting things ready for the user. So we are focusing on that to get his ready to use and demonstrated feasible fully controls open EDA stack for academia industry. So this can be used for academia industry both. So yeah. So these are the findings that we had up to now. Activities and all my colleague Sumanto will discuss. So as of now, has an question when you could proceed. Otherwise, yeah. Proceed my question. Yeah. All these upon buildings now. Mm.
Your main application and its dependencies, are they all built developed in a single language or they are different languages?
What common better? Sorry, bet.
Yeah, most of them are in Python only. Yeah.
And then when you build the snap, are you building from source or are you just building the binary parts in the snap?
Binary bus. Anyone else? Any other question? No, not Pullman as of now. Snap and Docker.
Hello. So, what made you think of this cloud-based simulation and do it in pure Python?
Can you repeat? Cloud-based simulation?
Yeah. What made you think about this cloud-based simulation and what made you think about pure Python? Why not other things?
Why not?
Why not other stuff like let's say you could have done it in other languages also, and yeah, let's say you could have done it in other way also.
So basically, the cloud-based. So we had the desktop version.
Yeah.
So desktop version used to create. So Snap and Docker are there, but so desktop again. People need bandwidth to download and this and that. But cloud-based is like it's portable. It's a system independent. They can directly use it. So because of this, we also support cloud simulation.
Okay.
Yeah.
So, cloud simulation means end to end, or there are particular parts which are being developed with the desktop part and the cloud part, or entire things on the cloud.
Those are separate, completely independent of each other.
Okay.
Yeah. So cloud part is completely independent of desktop. No, this.
Okay.
Any other? Any?
So I see the tool is similar to KiCad, right? So is it built out of KiCad or is it like a more like a
Yeah, it is a wrapper around the KiCad. You can
wrapper around
KiCad.
Okay, fine. And simulation part you're using Ngspice, right?
Yeah, correct.
Tool from analog devices as well called LT-Spice. How is it different from LT-Spice?
So DSpice doesn't have the niche signal simulation support. It's not an open source. It's a freeware. But this eSim is completely open source.
Okay, fine. So this is more like a tool which has everything like fabrication, correlation, and or
Not fabrication, but we are planning to include fabrication as well.
Oh.
PCM fabrication is there, PCD layouting is there, but VLSI fabrication we are thinking to include those also.
okay, got it.
Yes. Okay, so yeah, so to promote these tools, we have different other activities over here. So first of all, we have research migration projects, so where people take up different research papers and implement those circuits using our tool. And it's like converting proprietary to open source. And the ones who successfully do it get an honorarium and a certificate from FOSSEE. Similarly, we have something called circuit simulation project where it's there's students or academicians or the startups or whoever can take up some circuit from some other, or they can develop out of their own as well. And again they get a recognition on our web page and a certificate and honorarium. These things are done to motivate people to switch to the open source domain. And yeah, and similarly we have lab migration project, which is basically for academicians, where professors of various institutions take up various labs so they can switch to the open source. Then we also offer fellowships, internships. So we have summer fellowship activities, and currently the semester-long internship is going on. There are around 30 interns currently with us, and we and so it gives a great platform where everyone can collaborate and work together. We promote online internships as well as offline as well. Students can come to IIT Bombay and work over here. So both the ways it works. And this is a quick statistics, like what we have done and our outreach. We have conducted a workshop in 2019 with around 3,000 participants. Then we had a marathon. Recently, one more marathon was there with IHP Germany Fab in fabrication unit, and it was around it had 2,000 plus registrations and 40 plus completed surveys out of that. And we are trying to see how these things can go up till the space of fabrication. And our repository itself contains 600 plus circuits which are which are contributed by different students. They need not be an IITian, but they can be from anywhere, any part of the country or world. So they can submit on our repository. And yeah, so yeah, fellowships and internships, as I told that we have 30 plus interns. And this is a quick statistics of previous marathon. So some people who have participated in our activities went to different industries, and then are doing quite well in different industries. So yeah, so this is this is a promotional page, you can say. And our collaborators, so we are we are collaborating with IHP Fabrication Germany. Then we are also a part of India Semiconductor Division. We are trying to collaborate with SemiX at IIT Bombay. Then we are collaborating with the SOVESI processors, Ajit Sakti and Vega. So these things are there available in eSim, and yeah, so these are integrated with eSim, so one can try them out. And yeah, so there is lot of things written over here, but I would like to say just switch to the open source domain and start using the eSim on Ubuntu with the Snap and Docker support. So yeah, so thank you all. If any questions or anything, please feel free to ask me. Yeah, so just one more slide. So these are my contact details. If anything related to internship or any other query, please feel free to mail me or message me or whatever. You can contribute to our page directly. We are open to things. Okay. Oh, okay. Thank you.